Welcome students to IIT PAL problem solving session of mathematics. Our topic is probability and this is lecture number 6. As I said at the end of the last class, today we shall look at binomial distribution and use of binomial theorem in counting. If you remember, in the very first lecture I was talking about tossing a coin 3 times and noting the sequence of outcomes. And we have seen that the sequences T, 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 it can be T, T, H, T, H, T, H, T, T, H, H, T, H, T, H, T, H, H, and all three are H. Thus, there are 8 possible sequences when we are tossing a coin 3 times. The problem of such sequences is that these are not manipulable using mathematics. And more importantly, suppose there are 100 tosses and therefore there will be 2 to the power 100 many sequences. That is too large to handle. Therefore, what we bring in is called the concept of random variable. For you, I give a very simplified definition of random variable, which is as follows: a random variable is a mapping from the sample space omega to real number. This is not the complete definition, but at your level let us stick to this. Now, suppose with respect to the earlier experiment, consider x to be a random variable such that x of omega is equal to number of heads in the sequence. Therefore, since we have these 8 sequences T, 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 H, T, H, T, H, T, T, H, T, H, 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 T, T, H, H, and H, H, h. So, these are my omegas. Therefore, if we apply x, then what we get? There are 0 heads in this. These 3 leads to 1. These 3 leads to 2, and this leads to 3. Therefore, the random variable x takes values either 0 or 1 or 2 or 3. Notice that x takes values 0, 1, 2, 3 when number of tosses is equal to 3. Therefore, if number of tosses is n, then corresponding random variable x will take values 0, 1 up to n, because there can be no head, 1 heads up to all n tosses giving head. Another thing, notice that the probabilities of I belonging to 0, 1 up to n is not same for all I. As you can understand that with respect to x, when it is taking values 0, 1, 2, 3, then number of cases for 0 is 1, number of cases for 1 is equal to 3, number of cases for x is equal to 2 is 3, and number of cases for 3 is equal to 1. So, suppose P is the probability that the coin gives a head in one toss. Therefore, probability of TTT is equal to 1 minus P into 1 minus P into 1 minus P is equal to 1 minus P whole cube, which is often we write Q cube. Similarly, probability of one head is equal to probability of T T H plus probability of T H T plus probability of H T T is equal to Q Q P plus Q P Q plus P Q Q is equal to 3 times P Q square. Similarly, probability of 2H is coming out to be 3 P square Q, and probability of 3H is equal to P cube. We can see that the probabilities can be obtained by q plus p whole to the power 3, and probability that x is equal to y is therefore going to be, out of 3 you choose I positions, put a head there which can be done in this way, and then in the remaining positions you put q. In general, if a coin has probability p for head, then the random variable x giving the count of heads in n tosses can be obtained from q plus p whole to the power n, and probability x is equal to I is equal to NCI p to the power I q to the power n minus I. This is called the distribution or probability mass function. For binomial distribution with parameters n and p, which we often write as binomial in p. So, let us solve a few problems. Suppose we have x is a random variable following binomial 6, p. It is given that nine times probability of 4 is equal to probability of 2. What is the value of p? Answer: probability of 4 is, out of 6 tosses we are getting 4 heads, that is 6c4 p to the power 4 q to the power 6 minus 4, that is 2, and probability of 2 is equal to 6c2 p to the power 2 q to the power 4. Therefore, p2, that is probability of 2 upon probability of 4 is equal to 9. It is given, that is 6c2 p square q to the power 4 upon 6c4 p to the power 4 q square is equal to 9, that is q square upon p square is equal to 9, that is q by p is equal to 3. Because it cannot be negative, all probabilities are positive, therefore, q is equal to 3p. Now, p plus q is equal to 1. Therefore, p plus 3p is equal to 1 implies p is equal to 0.25 or 1 by 4. So, that is the answer. Another problem, suppose x follows binomial n comma p when n is equal to 8. Probability of 1 is equal to 0.2048 and probability of 2 is equal to 0.1024. Find the value of p. Therefore, probability of 1 is equal to 8c1 p to the power 1 q to the power 8 minus 1, that is 7, is equal to 0.2048. Probability of 2 is equal to 8c2 p square q to the power 6 is equal to 0.1024. Therefore, by dividing, we have 8 p q to the power 7 upon 8 c 2, which is equal to factorial 8 upon factorial 2 to factorial 6 p square q to the power 6 is equal to 0.2048 divided by 0.1024, or 8 p q to the power 7 divided by factorial 8 upon factorial 6. So, that is 7 into 8, that is 56, divided by 2 is equal to 28 p square q to the power 6 is equal to 2, or 2 upon 7 q by p is equal to 2, that is q is equal to 7 p. Therefore, value of p is equal to 1 upon 8. That is the answer. Now, an important concept of a random variable is its mean, or often it is called expectation. You know that the mean of a binomial n comma p random variable is equal to np, and its variance is np q. This you must have done in your textbooks or your classes. So, I am not deriving this formula. Let us do some problem. If the mean of a binomial random variable is 4 and its variance is half of its mean, then compute the probability that the random variable takes value greater than equal to 2. So, answer mean is equal to NP, variance is equal to NPQ, and given that NPQ is equal to half NP implies Q is equal to half. Therefore, P is equal to half. Therefore, mean is equal to 4 implies n into half is equal to 4 implies n is equal to 8. Therefore, we can get the complete distribution that it is binomial 8, half. We need to compute probability this random variable binomial 8, half random variable is greater than equal to 2. That is 1 minus probability of 0 minus probability of 1 is equal to 1 minus 8c0 half to the power 0, 1 minus half to the power 8 minus 8c1 half to the power 1 into half to the power 8 minus 1 is equal to 7 is equal to 1 minus 8c0 is equal to 1 half to the power 8 minus 8c1 is equal to 8 into half to the power 8 is equal to 1 minus 9 times half to the power 8 is equal to 1 minus 9 times 1 upon 256 is equal to 256 minus 9 upon 256 is equal to 247 upon 256. So, that is the probability that the random variable will take value greater than equal to 2. So, these are some simple problems on binomial distribution, and with that let me go to discussing use of binomial theorem in counting the number of certain events. For illustration, consider the problem that in how many ways you can have five different positive integers n1, n2, n3, n4 and n5 such that sigma ni I is equal to 1 to 5 is equal to 20. In fact, we have found that the number of solutions is 7. What are those? They are 1, 2, 3, 4 and 10, 1, 2, 3, 5 and 9, 1, 2, 3, 6, 8, 1, 2, 4, 5, 8, 1, 2, 4, 6, 7, 1, 3, 4, 5, 7 and 2, 3, 4, 5, 6. So, these are the 7 possible solutions, but we have done it in a mechanical way. As you can understand that first I have given maximum weight to the last one and then I tried to distribute that weight, keeping in mind that all 5 have to be distinct, and that way we have got the solutions. The problem is such a solution is not guaranteed to give all possible combinations. Therefore, I want to give you a mathematical way of obtaining the number of solutions. I am not going to give you the total exact solutions, but the total number of solutions, which in this case is 7. How to do that? The underlying concept is generating function. Which is essentially a power series which may be finite or infinite. So, let me first give you some example. In how many ways we can have two variables x and y such that 0 less than equal to x less than equal to 2 and 1 less than equal to y less than equal to 2 and x plus y is equal to 3. This solution is pretty simple. So, let us first draw a table x, y, and let us put their sum. X can take value 0, 1, 2 and y can take value only 1 and 2. Therefore, we have these 6 combinations, and the sums are 1, 2, 2, 3, 3, 4. Therefore, we can see that there are 2 cases when the sum is 3, 2 cases when the sum is 2, 1 case of 1 and 1 case of 4. So, how to do that? Consider the following 2 polynomials and compute their product. So, what are those polynomials? Because x takes the value 0, 1, 2, we write z to the power 0 plus z to the power 1 plus z to the power 2. And the second one is corresponding to y, which takes values only 1 and 2. Therefore, we write z to the power 1 plus z to the power 2 is equal to 1 plus z plus z square multiplied by z plus z square, and if we compute the product, we get z plus z square plus z cube plus z square plus z cube plus z to the power 4 is equal to z plus 2z square plus 2z cube plus z to the power 4. Now, can you find a similarity between this product and these numbers and cases? We have only 1 with z to the power 1, 2 with z square, 2 with z cube and 1 with z to the power 4. Thus, this polynomial gives the number of solutions for any combination adding up to say 1, 2, 3 and 4. So, this is the trick that allows us to solve many problems. Let me give you another example. Suppose we want to find out x plus y plus z is equal to 10 when 0 less than equal to x less than equal to 4, y greater than 0, that means it can take any positive integer, and z greater than equal to 0, that means it can take 0 also. Therefore, we want to find out the number of solutions such that x plus y plus z is equal to 10. So, by going in a similar way, therefore, we can write the following 3 polynomials. Because x takes the value between 0 to 4, so let us write them as x to the power 0 plus x to the power 1 plus x to the power 2 plus x to the power 3 plus x to the power 4 multiplied by y can take any positive values. So, that gives us an infinite series x plus x square plus x cube up to infinity multiplied by corresponding to z, because z starts from 0, we have 1 plus x square up to infinity. The theory is that if we compute the product and obtain the coefficient of x to the power 10, so that will give the number of possible solutions to the problem. So, let us try. We have 1 plus x square plus x cube plus x to the power 4 multiplied by x. If we take out x, then we get 1 plus x square up to infinity whole square. So, let us try to find out the coefficient of x to the power 10 in this. So, we have, let us write the first one as x plus x square plus x cube plus x to the power 4 plus x to the power 5 multiplied by 1 plus x square whole to the power 2. Therefore, we see that if we get the term for x to the power 5, that will be multiplied with this, x to the power 6, that will be multiplied by this, and x to the power 9, which will be multiplied by this, and that is going to give us the total number of ways of getting x to the power 10. Now, we know that one plus x square whole to the power n is equal to 1 upon 1 minus x whole to the power n, that is equal to 1 minus x whole to the power minus n, which can be written as 1 plus sigma over r is equal to 1 to infinity n minus 1 plus r, choose r, x to the power r. So, we are going to utilize this formula and try to solve this. Therefore, we need to find out coefficient of x to the power 9, x to the power 8 up to x to the power 5. So, let us first consider x to the power 5. Here n is equal to 2, r is equal to 5. Therefore, coefficient of x to the power 5 is equal to 2 plus 5 minus 1 C5, that is the coefficient of x to the power 5, because our formula is n plus r minus 1 C r is equal to 7 minus 1, that is 6 C 5 is equal to 6. Let us just try for x to the power 9. Therefore, here r is equal to 9, n is equal to 2. Therefore, coefficient of x to the power 9 is equal to 9 plus 2 minus 1 C 9 is equal to 10 C 9 is equal to 10. I am not solving this, but therefore, you can understand that the total number of possible solutions is equal to coefficient of 9, which is 10, coefficient of x to the power 9, which is 10, plus in a similar way it is going to be plus 9 plus 8 plus 7 plus coefficient of x to the power 5, which we have computed is equal to 6. This is 19 plus 8, 27 plus 7, 34 plus 6, that is 40. Therefore, the possible solutions is 40. Note that we are forming the power series corresponding to each variable by considering the values that it may take. For example, suppose we have the problem in how many ways we can get x plus y plus z is equal to 50 such that x is a multiple of 2, y is a multiple of 3, and z is positive and multiple of 5. These are, we are not given whether they are positive, therefore, x and y can take the value 0 also. Therefore, the number of solutions for x plus y plus z is equal to 50 with the above restriction will be given by coefficient of x to the power 50 in 1 plus x square plus x to the power 4 multiplied by 1 plus x cube plus x to the power 6 plus x to the power 9 multiplied by x to the power 5 plus x to the power 10 plus x to the power 15 and if we multiply these 3 power series and obtain the coefficient of x to the power 50, that is going to be the solution to this problem. Now, let me solve problems that we have done in the class, again in a mechanical way. So, let us recollect this problem. Our problem is that 0 less than n1 less than n2 less than n3 less than n4 less than n5, and it is given that sigma ni I is equal to 1 to 5 is equal to 20. In how many ways you can get it? Therefore, we start as follows. In order to maintain that these are all distinct, we do the following. Let m2 is equal to n2 minus n1, m3 is equal to n3 minus n2, m4 is equal to n4 minus n3, and n5 is equal to n5 minus n4. Therefore, n1 and m2, m3, m4, m5 are all greater than 0. Moreover, n1 plus n2 plus n3 plus n4 plus n5 is equal to 20. This we can write as 5n1 plus 4 n2 minus n1 plus 3 n3 minus n2 plus 2 n4 minus n3 plus n5 minus n4 is equal to 20, or 5n1 plus 4m2 plus 3m3 plus 2m4 plus m5 is equal to 20. When n1 and all mi greater than 0. Let us now make the following substitution. Say x1 is equal to n1 minus 1, x2 is equal to m2 minus 1, x3 is equal to m3 minus 1, x4 is equal to m4 minus 1, and x5 is equal to m5 minus 1. Therefore, each xi is greater than equal to 0, because these we knew are positive. Now, because we are subtracting 1, some of them may become 0. Therefore, 5x1 plus 4x2 plus 3x3 plus 2x4 plus x5 is equal to 5 times n1 minus 1 plus 4 times m2 minus 1 plus 3 times m3 minus 1 plus 2 times m4 minus 1 plus m5 minus 1 is equal to 20 minus 1 plus 2 plus 3 plus 4 plus 5 is equal to 20 minus 15 is equal to 5. Therefore, we get 5x1 plus 4x2 plus 3x3 plus 2x4 plus x5 is equal to 5 when xi greater than equal to 0. Now, 5x1 takes value 0, 5, 10 like that. 4x2 takes values 0, 4, 8, 12 like that. 3x3 takes values 0, 3, 6. 2x2 takes values 0, 2, 4, 6 and this is x4 and x5 takes values 0, 1, 2, 3 like that. Therefore, the power series for us is 1 plus x to the power 5 plus x to the power 10 multiplied by 1 plus x to the power 4 plus x to the power 8 multiplied by 1 plus x cube plus x 6 multiplied by 1 plus x square plus x 4 plus multiplied by 1 plus x square plus x cube. As you can understand, this is corresponding to this set of values, this is corresponding to this set of values, and finally, this is corresponding to this set of values. We need to compute the coefficient of x to the power 5. Since x to the power 5 is important, we need not think anything of more than 5 in this any of this power series. Therefore, the problem boils down to compute coefficient of x to the power 5 in 1 plus x to the power 5 multiplied by 1 plus x to the power 4 multiplied by 1 plus x to the power 3. We are not going any further because next term is x to the power 6, 1 plus x square plus x to the power 4, and this multiplied by 1 plus x square plus x cube plus x to the power 4 plus x to the power 5. Because we need all of them, I need not go anything beyond that, and we need to find out the coefficient of x to the power 5. So, let us start multiplication. These two are giving me 1 plus x to the power 4 plus x to the power 5. These two are giving me 1 plus x square plus x to the power 4 plus x cube plus x to the power 5 plus x to the power 7 multiplied by 1 plus x square plus x cube plus x to the power 4 plus x to the power 5. Now, since 7 is not needed, we can ignore it. Therefore, we have 1 plus x to the power 4 plus x to the power 5 multiplied by 1 plus x square plus x cube plus x to the power 4 plus x to the power 5 multiplied by 1 plus x square plus x cube plus x to the power 4 plus x to the power 5. Now, let us multiply this. We get 1 plus x square plus x cube plus x to the power 4 plus x to the power 5 by multiplying each one of them with 1 plus x to the power 4 plus x to the power 5. If I multiply these two with this one, plus we see that all other terms are going to be greater than 5. So, we do not need to get anything, multiplied by 1 plus x plus up to x to the power 5. This is equal to 1 plus x square plus x cube plus 2x to the power 4 plus 2x to the power 5 multiplied by 1 plus x plus up to x to the power 5. Therefore, coefficient of x to the power 5 is equal to 2 plus 2 plus 1 plus 1 plus 1 is equal to 7. Therefore, number of possible solutions is equal to 7. We have done a very similar problem, 0 less than n1 less than n2 less than n3 less than n4, and we wanted that the total should be such that sigma ni I is equal to 1 to 4 is equal to 16, and we found that the number of solutions is equal to 9. I leave that as an exercise. You follow the same technique to find that the coefficient of x to the power 16 is coming out to be 9. Okay, friends, I stop here today. So, in these 6 lectures, we have solved many problems in probability. I hope that these will help you in solving problems for your examinations where you may have to solve probability problems. Okay then, thank you so much.